The per unit cost in dollars of producing n items is given by that equation. Algebraically determine the minimum per unit cost and the number of items that should be produced to obtain the minimum. So I don't have to type this particular equation into the calculator because we can use the x equals the opposite of b over 2a to help us figure that out. What we know is that a is 0.125, b is negative 195, and c is the 77,325. And we don't even need the c on this one. We type it in. X equals the opposite of negative 195, there's the b, 2 times 0.125. If you have a fraction button, I recommend that you use it. I'm not going to use it because not everybody has it. And one other thing that I want to point out is negative and a negative gives us a positive. So we're going to go back to our regular screen here. I'm going to type this in. Again, if you have the fraction button, use the fraction button. But it's going to be 195 divided by, put parentheses in, if you are one of those who doesn't have a fraction button, it's 2 times 0.125, and that's going to give us our value there. So I think I'll put that in a minute. Of 780. 780 items. But then what it says is determine the minimum per unit cost in the number of items. That's the items, that's the n. The c is the cost, and that's going to be the y value. And what we're going to do is we're going to take that equation of 0.125, but instead of n, we're going to put 780 squared minus 195 times 780 plus 77,325. So one more time, we go back to our calculator. I like to use the store button on this kind of problem. You do not have to, and I won't use it here. But 0.125 times 780 squared minus 195 times 780 plus 77,325. And this is going to give us their cost. $1,275. And here comes the calculations for that. Flipping our paper over, the graph below shows the path of a football kick with the height above the ground as a function of the horizontal distance traveled, both in yards. And I recognize that I need to change the units on this one, so the height of a football is usually in feet, but I think they measure the rest of it, the distance, in yards. The function defining the path is given by that equation where h is the height of the football in yards and x is the horizontal distance thrown in yards. And the nice thing is on this particular problem is we really can see everything that we need. We don't need to type it back into the calculator. It says what is the height, what is the maximum height the football reaches. And that's the one part where you maybe can or can't see. So if we type the equation in, back here at the y equals, it's the negative 0.05 x squared plus x plus 1. The other nice part is if we go back and we look at this, we already have a window that we can use. We went from 0 to 21 on the x's. In fact, I'm going to go from negative 1 to 21 on the x's. And I'm going to go from negative 1, I think it's 9 on the screen, There's our picture. Same picture that's there. The only reason is, can you tell what the height is on this one? It's the only one that maybe is difficult. So just to check, we're going to go second, trace, and maximum. We're going to go a little bit to the left of what we think the highest point is. Enter. A little bit to the right. Enter. And then enter. And what it looks like here is that the maximum height, and I wrote it on my paper, I wrote 6 feet, even though I said the units were in yards. But once again, typically, if you put units, even though it's not the units that I specified, just looking for units. Second question, how many yards long is the kick? Well, that is this number right here, in black, which is the 21 yards. It says, from what height is the football kicked? Once again, a reminder that that is the y-intercept. So it's going to be 1 foot for 1 yard. Over what interval is the football falling towards the ground? Now we know this value here. It's falling to the ground from here to here. So it's going to be in between two values. The x value of this green point is 10. When the football lands on the ground, it's at 21.